Now we will go through the SOC code. Before jumping into the code, we will first see what all are the specifications of the SOC. So the name of the SOC here is an interconnect. So its duty is to connect two AXI clients with an OCP client. So the AXI clients are supposed to be act as masters, and the OCP client will be a slave. Now the interconnect has to arbitrate between the request that is coming from these two AXI masters in different channels, and it need to send it to OCP channel, and in the same way what all are the responses coming back from the slave has to be rerouted to the appropriate channels into the AXI masters. As you already know, in every AXI channels there are 5 different set of subchannels. So in an AXI protocol channel, there will be a write address channel, write data channel, and the write response channel, and a read address channel and read data channel. Thus, we have 2 set of those channels, which are AXI write ADDR channel 1, AXI write ADDR channel, write data channel 1, and so on. And next set is AXI write ADDR channel 2, and so on. So these 2 are a set of AXI channels. So you can see that the write address and write data request are inward request, and the write response is an outward request, which is coming from this interconnect to this slave, to the master, and the read address request is coming to the interconnect, and the read data response is driven back to the master. Thus overall, this is the block diagram of the interconnect that you are going to design. There are 2 set of AXI channels, and there are 5 different subchannels in every AXI channel as per the protocol, and there is an OCP channel, and these 2 AXI clients are acting as masters, and the OCP is acting as a slave. Now we will go through the implementation details. The whole interconnect design is split into multiple modules. So this is a general approach. When you're going for a design, you have to split the problem of designing into sub part or sub module, so that you can start from bottom and go to the top. So here in this approach, this is how I made decision to split the subunit. So you can see that there are 2 set of AXI channels, and it has to be routed to the OCP channels, and there is an arbitration mechanism which is deciding which request has to go out first if there are multiple requests. Thus I have decided to write a sub module called an AXI to OCP converter, which will deal with all the inwards request that is coming into this interconnect, and which will send to the OCP channel. Thus in this part, different write request and read request will be coming into this interconnect internally to this AXI to OCP converter module, and it will handle with all the requests, and it will store internally if needed, and these requests will be routed to the OCP channels. The write and read request coming from these 2 set of AXI channels will be routed to the OCP channels in accordance with the protocol that we define. Now the next part is, whenever there's a read request that is going out to the AXI channel, there will be a OCP channel, there will be a response coming back from the OCP slave. So that read response has to be routed back to the read data channel. So that is a protocol. There you need an OCP to AXI converter. So all these modules will be acting as an OCP to AXI converter box. And I have not added a wrapper around all these modules, but we'll be going through them in detail for every module. So in short, your interconnect will be having 2 parts, which is dealing with the AXI to OCP conversion and the arbitration, and an OCP to AXI converter which is dealing with the response coming back from the OCP client and distributing to the AXI read data channel.